We talked about the general training of large language models, and that training is global, as Ellie mentioned, and then Laszlo also talked about. And then the next step that we're doing with our AI model is we're teaching how we at NewPush, what is our voice, how we talk, what are our values, so that when AI starts to write something or help us, is an assistant, then it complies with our values, it complies with the way we think, the way we write. And then after that, so that basically gives a tone of voice for the AI. And then the third step is Joshua gave me a homework, which are the works that he has written that actually match with the theme that we're talking about here. So I didn't cheat in the sense that I read them all. But I was like, let's see what AI can do in terms of helping summarize, helping to figure out some bullet points. And I got to say that it did a fairly good job. I did have to correct a few things, but I was impressed. So definitely Ellie and team are doing an amazing work. Today, what I wanted to talk about is really learning. And we had already a bunch of really good questions from the audience and also from online about what is this LLM really? What is the engineering background here? Do we have like just a machine, you have input and output? And that's a very interesting topic. Actually, I'm going to go into a little bit in a couple of slides. But first of all, before we talk about machine learning, we need to understand, we need to get on the same page of what learning is, right? Because when you think about it, what is learning? Okay, so if we don't agree on the term learning, then it's hard. And there is this definition of machine learning that's taught in college. And basically, you guys probably already all read ahead, but still, I'm gonna read this definition. A computer program is set to learn from experience E with respect to some class of task T and performance measure P if its performance at task T as measured by P improves with experience. Okay, so that's basically a narrow definition of learning, but it is a working definition of learning. And so what Joshua then generalizes it a little bit is to extend that beyond machine learning to beings. We had that conversation earlier, Ellie and others in the audience, about, so are we a machine, or what is learning, or what is input-output? And so let's just generalize it to beings. When does an AI become sentient? That's another philosophical question, but let's just generalize this. So the same definition, but applying being. And we know that learning is more than that. So what we're going to say is that this definition of learning, we're going to call it spective learning. Spective learning, there is prospective learning and retrospective learning, so we're just going to take those words off of it, stem it, if you are in the language modeling, and we're just going to say it's spective learning. And basically, sometimes it can work and sometimes it is strange because first example, you learn like what fruit makes you sick, like you may be allergic to some fruit. You will then forage for other types of fruit because you want your overall health to be good, so you will eat food or fruits that make you healthy and not those that you're allergic to, right? So you're learning what works for you, for your body, etc., what you're allergic to. But then it can have a kind of unintended consequence of this definition. So you take a rock and you place this rock in a river, and as the water flows over time, that rock will be smoother and smoother. Those of you who know Latin, gutta cavat lapidem non vis et sepe cadendo, right? It's the water with enough time will shape anything, any object. Basically, but does the rock learn? Can we say it learns? We can argue that the rock is just subject to its surroundings. In this definition, one of the big things is performance. And what I also enjoyed, as some of you mentioned earlier, John from Neumann, or Neumann János in Hungary. We're in Budapest, so a lot of you know him as Neumann János. But his friends, Einstein and the other guys on the A-bomb team, they just called him Johnny, or Janchi, actually. And he actually wrote the first theory of the self-replicating automata. And that was actually one of the foundational elements in his theory, that you need to have some sort of performance measure. Because you need to basically see with relation to what are you going to improve in performance. And here, with LLMs, we're not even talking about the code being modified. So if you listen to Ellie's presentation, you may read between the lines that if a model doesn't work, you can make a $5 million mistake, but what you're going to do is you're going to retrain your model. You're not going to actually change the fundamental code, the fundamental model that you're using under the hood. It's not like us, as our genetic code from generation to generation, it evolves. Hopefully everybody believes in evolution here. But so there is a natural evolution, natural selection. And here we're not talking about this. So already with these large language models, this is the generic term behind what we call today AI, because that's the popular ChatGPT, all that. The large language model is what Ellie was talking about. This is the foundation today of the highest performing machine learning. But we need to understand that it has its limitations. And by understanding the limitations, it's also how we can most benefit from what it has to bring us. Okay? So we have to have the right expectations. When people have the wrong expectations, they are disillusioned after a while. But if they have the right expectation, they can maximize the use of the tool for what it is. So there is a couple of things about performance measures. I'm not going to list them all, since both of you who are listening to this online or here, you can read ahead of me, and you probably already read the bullet points. But these are the main concepts. The last bullet point here, however, I want to emphasize, because that's why we're so much in awe in front of large language models. And in conversations with Ellie, we actually discussed that some people are maybe in too much awe in front of these large language models, because just because a large language model can read an encyclopedia just like that. Actually, it can read it in a blink of an eye. And actually, as Ellie alluded to it, they trained billions of parameters, hundreds of millions of pages. In what time, Ellie? What's the training time? Few weeks. So in few weeks, you can read 500 million pages. Okay, so that gives you a scale. Like a human would need several lifetimes to read just a fraction of what that model ingests. And so some people think that, okay, so that model has an unlimited capacity, and eventually it will be as smart as a human and will be able to reason. But today, in my talk, I just wanted to set the right expectations, that some of the fear-mongering around that is not right. Actually, the future is bright, this technology is fantastic, and it's not gonna be this nefarious thing that takes over. It does have dangers. In our next presentation with András, who comes after, we will show that just like any tool, just like any weapon, you can use it for good or for bad. But that's no different than any other tool that us humans we invented, right? Even with a screwdriver, we can hurt someone or we can build something. It's our choice as humans. And of course, we have to put, in that sense, the right regulations on humans. But AI by itself doesn't necessarily need new regulation. It may need new way of enforcing regulation, because you need to be gentle to each other. You need to use the tools for good. We already have that in our laws. We already have that. It's just a different way of enforcing that we need to think about. So looking at the other thing is agency. So agency is, again, a concept that people have studied for a long time, and there isn't necessarily a consensus around, and that's maybe the first step. And what's really interesting about ChatGPT, it is the first time we have a tool where we can claim to a certain extent that it has agency. And I'm not saying independent intelligence. So that's why I have this slide about defining agency. That's something that Joshua spent quite a bit of time on laying down the foundations of the definitions. Because a lot of time AI experts get into arguments, or even non-experts, but people who think they know about AI, and they start arguing about something, but they don't have the definitions down. So you don't even know what they're arguing about. They're just having a philosophical argument about there's no foundation. So is that really an argument, or is this just people trying to voice their opinions, but there is no real value to it, right? Because if you don't build on strong foundations, is there value? You can ask yourself. So this is one of the things that Joshua wanted to do, is to make us think about, okay, what are we really talking about? What is learning? What is agency? And take it in a little bit of a historical perspective, and also just figuring out, so is AI guided by itself? Is it guided by its own knowledge? Is it guided by external stimuli? Is it a combination of the two? And then when we look at humans, us humans, we have some similar questions about ourselves. And we weigh, maybe we sometimes even, we shouldn't, but we judge each other. We're like, oh, this guy is too influenceable by someone, or this guy is too much of a hard-headed, he's only doing what he wants and not taking into account the outside world. And ChatGPT, with a lot of the bounds that's put on it, can be very heavily influenced, but at the same time, we saw in Eli's talk that it can also have a very fundamental bias based on how it was taught. And at that point, you must say, can you predict what ChatGPT, can you predict what a large language model will say in a given situation? And the short answer is not really. And therefore, there is a strong argument to be made that there is some agency to be talked about here. So we are truly making a step towards a type of machine learning, a type of intelligence, artificial intelligence, that we've never dealt before with. And so that can be scary, actually. But at the same time, I want to make sure that we don't get scared, because there's too much fear-mongering. There is too much baseless attacks on the large language models. They're very powerful, but they are not about to take over the world in the sense of on their own volition. And that's part of what I want to explain here. The term agency is quite complex, as I alluded to it. And really, at the end of the day, what's the most important to take away is that to establish whether there is agency or non-agency with ChatGPT or large language models, it's not even a crucial piece of evaluating how they learn, or are they capable of learning. And I think that, and maybe in the question section we can have and in the roundtable we can have a conversation with Ellie, but I think it has been now established that large language models can learn, okay? They don't learn, like humans cannot just read the encyclopedia like that. So there is a different type of effectiveness or efficiency of the learning, but they definitely can learn, and they definitely can give us answers that we may not have thought about, but as we read them, we're like, this is a good answer, this is helpful to me, it makes sense. Or I can actually validate that. I can use it as my assistant, maybe as a junior assistant. Maybe for some people it's more like a senior assistant. It really depends on what the topic is, how much creativity is needed, because the higher you go in the creativity, the higher maybe the level of training is needed for the model. But we gotta also realize that nobody has proven yet that this model can be trained to infinity and become like a godlike power. This is some people who want to do fear-mongering about LLM, they say it can, but nobody has proven it. Given how, in a way, inefficient the learning is, as Ellie mentioned and as Laszlo mentioned, we have to ingest hundreds of millions of data points for it to start giving us accurate answers. Like a child at 6 years old, they don't even know how to read. They had barely ingested some words from the human, and they can give you intelligent responses. They can watch one movie, and a clever child will basically tell you what was the plot in the movie and things like that. Ingesting such a small quantity of data, there's no large language model that could do it. And by definition, it wouldn't be a large language model, right? Because it would a large language model, by definition, needs to ingest a lot of data before it starts to be useful. So that's the key takeaway about the agency, that when you get sucked into a debate whether a large language model has agency or no agency, it's probably not the right debate, because we established that it can learn, and by learning it can be useful. So there is also like a lot of questions about how does ChatGPT work, and why are we in awe and at the same time afraid? And clearly, ChatGPT doesn't learn like we do. So as I alluded to it, it's a different type of learning, but it definitely does not possess a sentient agency. This Google engineer who got scared because he felt like Google Bard was sentient, and it could, just because it can fake it, it's not, sometimes people can say, fake it till you make it. Large language models cannot fake it till they make it. They can fake it, but they cannot make it. So they cannot turn sentient just because they can fake to be sentient. You can tell a large language model, pretend to be a mechanical engineer, and then you can tell it, okay, so give me the drawing of an engine, a combustion engine, and then it can give you a really good combustion engine drawing. But if you say, now I want to invent a new type of combustion engine that's radically different than the existing ones, it would not be able to do it for you, because there has been no data ingested about that. Okay. Of course, there could be dots that it connects that may be novel, and there can be innovation. There can be innovation by combination, but there are some limits to that type of innovation that is certainly not going to be a free-willed type innovation. And enhancing its own code, that's something that it's not made for. And unless, on some of these things, I'm telling you my own understanding. We have experts that are smarter than me here, so after that, in the conversations, we can get into a a conversation about that and see, what we have. There's one other thing that Joshua taught me more recently, and that's, we alluded to that in earlier questions, and that's called the Chinese room argument. And the Chinese room argument is, imagine you have a room there is only a way to communicate in and out of the room with the outside world can ask a question in English, and the guy in the room has every possible question that can be asked, and it has the Chinese answer to it. And so what the guy does in the room is he finds the English question, and then he responds in Chinese. And so from the outside world, and actually you can do it just in Chinese, by the way. So you ask the question in Chinese, and the response is in Chinese. It actually works with any language. The point is, just because he has all the questions and all the answers, does it make the person in the room know Chinese? Like from the outside world perspective, does it make a difference? You don't care, right? Because all you know is you're going to ask a question in Chinese and it's going to know the answer in Chinese. From your perspective, you will not know the difference. And that's why when people go too much in the details of how model works, then they are having the wrong conversation. Because it's, what is our goal? Earlier, one of our listeners was asking the question, for my company, what does it mean for my company? How do I use it? What are the risks? And if you want your company to benefit from a technology, you don't really care what's under the hood. As long as it does the work and helps your team members be more effective, you're happy with that. Of course, there was a side of your question about the risk, and you want to minimize the risk. You want to avoid the risk. But here, if there is no risk, just the technology, as long as it gets the job done, you don't care what is inside. And that's another debate that we got to be careful about. People get lost in the detail of how ChatGPT learns and just make assumptions. And so one of the arguments we often have about ChatGPT is that about learning that ChatGPT clearly doesn't learn like humans, not just because it can ingest so much, but because you can ask ChatGPT any complex multiplication and it will fail. Like you ask ChatGPT a large number to be multiplied by a large number and you will see it fails. If ChatGPT recognizes that it can use the Wolfram Alpha plugin to get the result, it will get the Wolfram Alpha plugin's result and it will give it up to you. And that's where the Chinese room argument comes in. Does it matter for us that ChatGPT doesn't know how to multiply? What matters is that it's giving us the right answer, right? So we gotta be careful when what is our goal in our argument? If it is just to evaluate the way large language models learn, yes, large language models don't know how to learn mathematics. But if it's about, can I actually solve all these problems with large language models? Yeah, ChatGPT or Ellie would be very happy to say, hey, we will customize this LLM for you in any way your enterprise needs. We're going to plug in your ERP. We're going to do whatever you need. And then it will be able to give all the answers. Or we're talking about NewPush, the same thing. For security, we can plug in, it can be your CISO. Of course, Laszlo will be mad at me because he still wants his job. So we're going to be careful about these debates when we get into the debate, that not spend time on the wrong questions. I jumped the gun. I talked a lot about the learning capability of ChatGPT. So let's see if there is any point that I haven't touched on yet. Okay, so there's one important thing. Humans learn usually because they're curious. Except when we're younger, when our mom says, you gotta go to school. But actually, we don't really learn that when we're forced to do it. We learn far better when we're allowed to learn because we want to learn. And we see in the schools, like types of Waldorf schools and things like that, where children are more free to learn at their own pace. They actually learn better and deeper than in places where they basically are forced, sometimes even with brute force, to learn something. Then they pass the exam and then they just want to forget. By and large, the effective learning comes from curiosity. You will not see ChatGPT go out and start rummaging through content on the web and try to learn something more. There is no intrinsic interest for knowledge in ChatGPT. The ChatGPT gets a basic training, $5 million, whatever, and then Ellie's team comes in and can customize. Actually, they can do the basic training too, by the way. But at the end of the day, it will get the training you give it. Okay? In that sense, it's like the perfect student. It's like he's not doing more. He's not doing less, but he's doing exactly what you ask it to do. It will learn what you want it to do, and then it will be able to regurgitate what he learned without fail. He's never going to be depressed, never going to be sick. As long as you power it, it's going to work and it's going to give you the answers. But it's never going to tell you, hey, I want to learn more about this type of engineering. I want to learn more about the language or anything like that. There is ongoing research about, okay, but how can we expand these learning capabilities? So by far, we're not at the limit of what just large language models can do. So there is one research area is how these large language models can evolve. And then there is the other research area is, we alluded to it earlier in our previous sessions, is the ethical and societal implications. And we had actually very interesting conversations in the break. Some of you were mentioning, so culture is nice, but what about politics? And even today, like we have, when there is a political organization in power, they tend to like to own the media, right? That has nothing to do with ChatGPT. That's our nature as humans. We take power and then we want to promote that power and promote the ideas of that power. So ChatGPT just becomes another tool for that promotion. The political powers to be could say, hey, we're going to train it to the culture, but then let's add a little bit of our ideology to it, and let's bias it with a little bit of our ideology. And in fact, that's actually why, for example, Ellie's company is doing so well, because the large companies in the US have, by and large, all went to just one type of ideology that all these LLMs are regurgitating. And it turns out that ideology is not necessarily a mainstream ideology. They would like it maybe to be mainstream, but it turns out that it's maybe a fringe ideology, and maybe the mainstream ideology that helps humanity move forward is actually a different ideology. And this was really the impetus for me to invite Ellie and to talk to you guys that there is another way. There is an alternative. Each country that wants to preserve its culture has the ability to create their own large language model and ensure that their children can go to an AI device that will give an answer that's based on the culture of your country, so that the culture is preserved. Because if everybody goes to just the general LLMs that are available today in the mainstream, then everybody will embrace just the one single woke culture, which may be fine for some people, but may not be fine for others. And for certainty, it will destroy all the cultures in the world, because it could be just one unique culture at the end. And as humans, obviously, we know that's not the answer, because we want to preserve all of the cultures, and we want to make sure that these cultures are passed on to our children. And that's how we evolved. So maybe that's the most fundamental danger with a large language model, is to unify all the cultures and destroy the richness of humanity with the variety of the cultures. I touched on it, but this is a topic that comes up a lot, and you guys heard Google fired that engineer. I don't know, there was a big brouhaha about it a few months ago. Maybe some of you knew the exact date. And that engineer seemed truly concerned and truly worried about the sentience. And some people may have thought that, okay, the sentience of large language models is underestimated. But at the end of the day, when you look deeply into it, the worry of very smart people like Elon Musk about artificial intelligence is not the current state of large language models, is more as we evolve in AI to the next generations. And I'm not talking about multimodal AIs. Well, you will hear the term multimodal AI. That's just basically a large language model that is then applied to images. It applies to, Ellie, you correct me if I'm wrong, but multimedia in a way, right? So it's not just text media, it's video media, sound, etc. And it's true that the multimodal large language models can actually connect more dots, and they can actually learn more interesting things. But they're still LLMs. There's still this threshold of getting through sentience is not here, because they still learn with ingesting a massive amount of data and be able to create a model for that data that they ingested, but they don't learn like humans. Now, we may say, is human learning optimal? Who knows? Okay, this is not a subjective question. Do we learn optimally? But we can actually say that because we can be comparably smart to a ChatGPT with much fewer books. So there is some effectiveness in our learning models. So what Joshua and his research students are doing is to study what is into learning. How do we get better learning? And what is learning in the first place? So that's why I started this talk about defining learning. And just a little bit ironically maybe, but small issues like defining what is intelligence is also a question. Because we talk about artificial intelligence, but what is artificial intelligence? In fact, sometimes scientifically they call these models artificial stupidity because we can actually get them to be really stupid. Sometimes we judge each other, we say, oh, this guy is really stupid, etc. It's not a nice thing to do, by the way, but we do it, we're humans, sometimes it happens. Same thing can happen to artificial intelligence. And when it's really bad, then what happens is what Ellie mentioned. We just wipe it off. We're not going to try to troubleshoot why it's wrong. We're just going to wipe it and retrain it. If you think of the human context, it would be pretty bad because that's like the death penalty. Except that there is no retraining. We just say, hey, there's enough new humans created, so we're just doing that. Anyway, what can we do? What are next steps? Where is the research going? What are we opening up to? What are interesting topics? So if you guys want to research what types of things, and Ali probably can add more to this, but just those that my conversations with Joshua yielded, obviously looking at the performance measures. The performance measures are very important because John von Neumann defined that as one of the key characteristics to creating artificial life. So John von Neumann actually defined how to create artificial life way before we had any compute capacity for artificial intelligence. Not just that, but he also predicted that we have genes, that we have the whole concept of genetics. He predicted it before DNS and RNS were found, really. So he died 10 years, at least 10 years before the discovery of DNS. Okay, so that's just to give you the context of how visionary this guy was. And for computers to be able to basically create the self-replicating, which LLMs are not. LLMs, you cannot create a self-replicating automata with LLMs. You basically need to have the right performance measures. And the first people who created these artificial life, they did it actually in late 60s, early 70s with machines like Commodore 64, if those of you are old enough to remember. Ellie is too young, of course. Yeah, let's hide. Let's not reveal our age. But basically, and because it's so fragile, like when you try to do it in, I think it was Holland, John Holland, that tried to do it as a postdoc student. And it took him like many tries, and he had a main job, and he was just looking at the computer, and one night he said, oh, it worked. And the parameters are so fine-tuned to make artificial life work that when Elon Musk says that human intelligence is such a tiny, fragile flicker, that's really, there is a lot of truth to that for all of these things to come together, all these parameters that allow us to basically learn and evolve and try to be better. This is very fragile. This is a very narrow parameters within which you can have life that evolves and doesn't self-destruct. In fact, as there is this clock, famous clock, they say the midnight clock, like how close to humanity is to self-extinction. And that's also very true. But we're always close to midnight in a way, because I think the more we evolve, the more there is also risk. I believe the future is bright, but I don't believe that the future is riskless. So we have to be careful and we have to worry about it. And that's also, I'm very grateful to the Rotary Association, to clubs, to put up this symposium, because I think it's important we think about these problems. And so by now you probably read ahead of time of all my bullet points, but there is, again, back to some of your questions, there is a lot of study to be done on the transformative impact. Some people ask which jobs are going to be taken away. I think it's the wrong question. I don't think jobs are going to be taken away. I think jobs are going to change, and jobs are going to get more interesting, more fun, because instead of having to do the heavy lifting, in Hungarian there's a good word for that, which means anybody help me out? That's the wood chopping work. The wood chopping work, that's the heavy lifting. These models will help us with it. And so everybody who works in any domain where this can be more powerful. An Uber driver, he doesn't have to drive the car. He can drive a fleet of 20 Uber cars, and he just needs to worry about the one that gets stuck in traffic and that AI doesn't know what to do, and then he will override the controls of that AI and get it out of this problem that it has. And now suddenly, instead of driving one car, he can drive 20, okay? in every example where you can give me that it will take somebody's job, I will give you the counterexample how this person will have a more fun, more rewarding job, where he will actually elevate to solving more interesting problems every day. Okay? And then it brings an abundance of wealth to humans. We already, even the poorest among us, live better than kings used to live. Kings didn't have penicillin. Their children died of very simple diseases. And today, everyone can have access to antibiotics, and more people, let's put it that way. I know that it's not ubiquitous everywhere in the world, and we're still working on that, but it's by and large accessible to a much wider range of the population. So these advancements, we have to look at it from the bright side, that the future is bright, and we need to leverage these tools to the most of what we can to make humanity better, to preserve that flicker of intelligence in this vast expanse of what the universe is. That's my talk for today. We have also some references that I added if you want further reading, but that's Laszlo.
Thank you very much for your presentation. It was very interesting. Thanks. I think you summarized the main elements of a good AI framework. You mentioned a lot of things about the importance of the performance measures and how the learnings works, how the language models can be learned, and also you mentioned the ChatGPT, say, beyond the scenes. Thank you for that. It was new information for me, for myself as well. So I think it was a brilliant summary for the whole big picture. So thank you again. Questions?
I have participated in a discourse about development of AI, and we faced with a question. It was just a learning group. Which one is more important to develop AI further? The quantity of data, quality of data, the capabilities of the algorithm, or simply just the computing power? And because we are simple guys, we could not answer that, but I'm very curious about your opinion.
So I am biased in this topic because we work on cybersecurity, first of all, and secondly, we took an approach to cybersecurity, a data foundational approach, where one of our philosophies is that you have to have 100% completeness and accuracy. So 99.999, which is acceptable in telco downtime, is for us not acceptable. And secondly, we need to ingest as much different kind of data as we possibly can. So what happens when you do that is garbage in, garbage out. So to me, my answer, my biased answer, so my eye in there is very biased. I believe that first comes data quality. If you're not going to be able to produce quality data in small quantities, then in large quantities you'll be in bigger trouble, because the models will learn something. It's like your kids. If your kids see quality examples, and they will become quality kids. If your kids see garbage, then they won't be as effective in life. And first, you need to be able to monitor data quality. And once you have mastered data quality, you can increase the quantity, because then you try to scale it. Okay, so that's the story of our company as well. Our customers threw harder and harder problems at us, scaling bigger and bigger. But the foundation is data quality. And most IT projects, even before the age of AI, they failed on data quality. 75% of IT transformation projects were known to be failing. And maybe the number is even higher. And every time we looked closer to a project, we found a data quality problem that was at the root. What AI does is it accentuates this. And Ellie can maybe talk to that maybe at the round table or now if you want, Ellie. But so my personal belief is first you focus on quality, only then you focus on quantity.
Really interesting and beautiful presentation, and your introduction was really interesting. You mentioned that we call that learning as aspective learning. And it's interesting that if something is predefined, even the learning of the machine in the future, then can we talk about prospective learning? Or what do you feel, and all the panelists, have you the experience that something happens without predefined as a prospective learning of the machine, or is only a retrospective one?
So I think, and there you're reaching the limits of my knowledge, so I'm not as smart. So thank you for the kind words, but I'm learning. I'm still learning. I have a lot to learn. My understanding is that LLMs can do both prospecting and retrospective learning, but they cannot do other types of learning. So when it comes to spective learning, LLMs are reasonably good. And in certain types are far better than humans. Okay? okay? But when it comes to learning rational thought, when it comes to learning logic or learning math, that's where you encounter the problem. And math is not about retrospective or math is like fundamental rules. And this is why it's amazing to cite John von Neumann, because a lot of people don't know, but he was a friend of Einstein. And when Einstein couldn't solve a math problem, he called Johnny. And then when the US military knew that Johnny was the guy who Einstein would call when he has a problem in math, and so they would fly him over and they would blackboard together. At the time there weren't whiteboards, so they would blackboard together the solution. And then when Einstein was like, I got it, okay, then they would fly back Johnny to wherever he needed to continue his work, and until Einstein got stuck again. That's pure math. And we have not created yet any intelligence or any type of intelligence learning that can learn math. Okay, we have learned math in the way that Johnny could. Because like Wolfram Alpha is amazing. Like any math problems that have already been solved, it will be able to solve it for you without you knowing math. But I'm talking about proving new theorems. Wolfram Alpha, I do not believe that is capable of solving new theorems. And I don't believe that we have any AI that's capable of solving new theorems. Theorems that haven't been proven yet. And John von Neumann, when he was in high school, and his teacher, whose name was also Rats Laszlo, our friend here, who gave the presentation, his teacher said, hey, there is nothing more I can teach you. And that math teacher was pretty smart. He's at one of the best high schools in Hungary, Fasor, those of you who guys know. And I cannot teach you anything anymore. And Johnny was, I think, 14 or something like that. So he says, I'm going to introduce you to the teacher at the university. And that university professor, and I'm very bad with names, and an IT guy, so I apologize, I don't recall, but that university professor told Johnny, hey, I was working on this theorem for the past few years, and I couldn't solve it, so why don't you help me solve that theorem? And Johnny went to work, and 6 months later, he had it solved. And then the professor was like, wow, okay, so you're the real deal. But that's just to set the context. That type of artificial intelligence, I don't think we have it, and according to those experts that I talk to and that I trust personally, we're at least 10 years away from that type. But it doesn't mean that we're 10 years away from other huge breakthroughs. I mean, fantastic pioneers like Ellie and the team, they are working on new stuff with LLM and multimodal LLM and other things that we will have a ton of breakthroughs. And maybe like the self-driving car will be good enough with just doing it with LLMs, or maybe LLMs augmented with the Chinese room concept that I just mentioned. But that's the type of learning. So the spective learning, I think, yes. Other types of learning, not yet.
So first of all, thank you for the talk. My question is, do you think that the world is hugely overestimating the potential AI has right now? Because for some reason, we humans have the notion that if we ask a question and somebody intelligently answers us, we assume it's a human, right? When you type in your question to ChatGPT and it gives you a proper answer, you think it's a human, right? Somewhere behind the screen. Now, people it scared the bejesus out of people, losing jobs, and the whole world is coming to an end, and this is going to be dangerous and all of that. Do you think this is all over-promised or assumed, and the technology is so far away from it that we're decades away from something that we think AI is today? Because what you are suggesting is that AI today is nothing else but a powerful machine that can read zillions of pages within 10 seconds, and that's it.
Well,
so
but
are
that's
we
a big deal.
overestimating AI today?
So that's a big deal, but it's a very good question so thank you very much for this question. We work with Gartner, Gartner is a big analyst firm. There's also Forrester and IDC are other big analyst firms, and there's many other lesser known analyst firms. And the folks at Gartner, they have like this really neat like process that they go through, which they build what they call and so they define the hype cycle as there is the beginning of a new technology. So they only put a new technology on the map when there is enough traction already. So there has to be millions of dollars from the economy. I don't know how many millions, but many millions of dollars impact on the economy. And then it starts going up. And there is the top of the hype cycle, which is it's overhyped. And then they go down. Sorry, I should show it like that. They go down, and at the bottom of the hype cycle, there's the trough of disillusionment. And then some technologies die there in the trough of disillusionment. But some technologies go up and they go into the plateau of productivity. Okay, I think with AI, it's like incredible because I think AI is like, from that perspective, like a quantic entity that it's all over at the same time of that curve. It's at the beginning, it's overhyped, it's in trust of disillusionment, and it's reached the plateau productivity. And it just depends the application that you're looking at. But for chopping wood, I think it's a disillusionment because you cannot chop wood today with AI. But for helping you write a presentation, helping you write business emails, helping you extract from contracts the essence, the key points in contracts to pay attention, or the points in a contract that are gaps. Like you can literally tell LLM, show me the gaps in this document. And it will tell you, okay, these are the gaps. There is a lot of things that are today, I may sound like a horrible boss with what I'm going to say, but in my company, if somebody doesn't use AI on a day-to-day basis, then they cannot stay, okay? Because they are basically not performing well enough for what we pay them for, okay? I prefer to have fewer people with higher performance that are better paid than have a bunch of people with average performance. And so AI is obligatory. But to Laszlo's point, we also have to be very careful how we use it, what we use it. Some people wanted to go to ChatGPT, and we said no, because all the company information is going to be leaked out. So we're very cautious about how you use AI, but we're also very strong about you have to use AI. Do you have to use it with everything? No, but those applications that I mentioned, some business applications. The other thing is, like Laszlo's team, they can build scripts much faster. Because you don't have to type 100 lines of code. It will generate for you 100 lines of code. You just have to say, okay, this is my idea. This is what I want the code for. And if you already know how to write code, you can use this much better. If you never wrote code, you will not be able to properly explain how to write this code. And that's why there is this meme, there's this joke going on around the internet for, it says, ChatGPT will write the right code if you specify it correctly. And then the developer says, cool, we have job security. Okay, because really the only people who understand how to specify are the people who know also how to write code, because usually business people have a hard time formulating in terms of the John from Neumann algorithm language on what is it that they really need. And so the people who specify, who can translate business specifications to technical specifications, they are the ones who can really incredibly increase in performance. But also the coders who code every day, they know a number of things that need to be done. It takes a lot of time, and ChatGPT a large language model will actually get it done for them. And I don't want to jump the gun on András's presentation, but he will dive into that topic a little more. So I'm going to stop here on that topic.
So we have some questions from YouTube.
Okay. First question is, how do we handle reality that so much of what is used to train models is either weakly connected to fact or downright false? So to me, that question goes back to data quality. You need to make sure that you can feed your models good quality data. And that's not an easy thing to do. In our world, in cybersecurity or in pure IT, ensuring data quality is somewhat easier, but it's still a science. We started doing that internally for a decade. We somehow had this intuition that data quality is going to be pivotal. And we also had the intuition that AI is going to be pivotal. To be honest, I didn't know how important data quality will be. I just knew, and our team knew, it's going to be really important. So we worked on data quality for a long time, but we know that it's very domain specific. So when we showed what we were doing to Johns Hopkins, to some of the largest labs there, they asked us, do you guys know what you're doing? And honest answer, no, we don't really know what we're doing. So they say, you guys are building the ontology of cybersecurity. And I was like, oh, what is ontology? So I went to look up ontology because I forgot. I learned some point what ontology meant. But ontology means you're describing nature, you're describing science, you're describing the terminology, basically. So you're building terminology that allows to know what we're talking about. And this is what we started today in this presentation from Joshua, defining learning. What will we call learning? What type of learning are we going to talk about? This data quality issue is really the key. And I'm not saying it's going to be easy to do. I'm not even saying it's going to be simple to do in every subject matter. But the subject matter experts in any area are the ones who can define what data quality will look like. Okay, so that would be my answer to that. The next question is, we have actually quite a few, so be prepared. Do you foresee the models to also become efficient in an unpredictable situation? It's like the French would say the Normand answer, basically yes and no. Okay, in some situations, they can connect the dots and they can give you an answer in something that they may not have seen, but in a situation that has a structure of what they have seen. Okay, so if the structure of the situation is something that can be then deduced from their knowledge, the model that they built, the way the model was trained, I believe it doesn't have to be something that they already know. And actually, can somebody give the mic to Ellie, because I really want Ellie to respond to that, because I don't know if what I'm saying is accurate. So I believe a model in that sense can answer to something that's unforeseen. But if something is completely a new domain, I don't think the model will necessarily be able to handle it. Ellie, what do you think?
Actually, I think you're right on track. So this kind of ties to the way of thinking that models do, and a lot of what the models do today is what we call deduction. So you have a set of data that you've seen in the past, or you have data that you have been trained on, and you can make certain deductions or a limited amount of reasoning on that data. Now, it's very impressive when you see that, because a lot of what we do today in the world is deduction. We don't invent a new theoretical result or we don't prove, most of us don't go around proving new math theorems all day, although it's really impressive to do that, and I think that's actually what moves humanity forward. That's not what most of us do during our day-to-day regular life. So deduction is a very powerful tool, but it has a downside where you really need to see at least something somewhat similar to what you're trying to deduce in the past. And if the deduction chain, so you have to have what we call multi-hop reasoning, where you need to jump pretty far forward in your reasoning abilities in order to deduce something, then this is something that is currently a weakness. And this might be a bit controversial, but I think that it will not take decades for models to get to a point where they can do much more complex reasoning and deduction. It will take only a few years. And this is based on the research that we're seeing right now. Now, nothing is promised, but this is just my opinion based on what I know. And I think that not only that, but they will. So if I have to say right now, a model like ChatGPT is good in pretty much every topic that you can ask it. So, but you might know about a specific topic more than ChatGPT would know, because you're an expert in that topic. But so overall, it would probably know more about Egyptian history than me, but probably would know less about AI than me, or about security than you. But I think that as we go into the next 5 years, it would become smarter and smarter, to the point that I think that it will be in the top 10% of everything, pretty much. So everything that can be done in a computer, and I'm sorry, you would still have to chop your wood for the next 2 years, but almost everything that can be done inside a computer, so what we call knowledge work, would be done on the highest level using language models. But again, this is not consensus yet.
Thank you. So the next question actually ties into what you just touched on, Ellie, last, which is the recency of the information. So the question is, as we consider that true science is asking questions and getting new and potentially different answers going forward, if AI doesn't have the newest data, what then? And that was, for me, as a user of AI, that was one of my big frustrations, that these models are trained, and then they tell you, hey, it's trained with data up to 2020 or up to 2021 or something, so you cannot ask something that's beyond that. So what is the answer to that?
This was the case, and I think that many people were very frustrated when they tried using ChatGPT to ask about the recent news or who won a football game last night. This is not really the case anymore, because first of all, retraining the model becomes easier today. So once you have a specific model that you trained on specific data used to be quite hard. It meant you have to retrain the entire model, but using newer techniques today, we're actually capable of injecting new information all the time into those models. So you can actually have a system like ChatGPT that stays up to date with information all the time. So that kind of problem that we used to have in the past, in the beginning of language models, is less relevant today, just because, and for example, in our system, in MetaDialog, in the platform, the model continuously learns all the time. So whenever, if you integrate into some business and you change even as the tiniest detail, you change the prices of one of your products, the model will pick it up immediately, and the next time you ask it that question, it will already give you the updated data.
For my edification, what was the reason that in older models they stopped the training like that and didn't continue to update them?
There's two main things. First of all, when we just started, the way we used models were we just gave them input and got output from the other hand. Today, we use them in much more complex ways. So the models are actually wrapped around with other AI models that are capable of injecting them this new kind of data. Now, it will not improve their abilities. When we talk about injecting new data, we're talking about injecting facts in a sense, okay? If the model doesn't know math, for example, it doesn't matter how much new information about math you inject in this way, will not learn math. But if you give it news, it will be able to use that new information to talk about those subjects. So it doesn't really give new capabilities to the models. This is still hard, and this still requires retraining from scratch today. If you want to train it on a new subject that it never seen before, you really need to retrain the model. But it's less relevant when we're talking about changes and about adding new information to the model.
Okay, thank you. Next question. If the AI has both new and old data, how well can it tell that the new supersedes the old?
The quick answer is it can't unless you trained it with dates. So unless you gave it some understanding of dates when you trained the data and you basically provided dates for the data that you used, it's really hard. Again, this kind of ties to the reasoning capabilities of the model. If you give me a few articles about different battles, I would probably be able to deduce at some point which battle came before some other battle, but this is not as easy to do to an LLM today because of some of the reasoning capabilities. We have different techniques, again, to inject that kind of data understanding and which data we want to prioritize when we train those kind of models, but you need to think about it in advance, and if you don't do that, then it might be a problem.
Excellent. Actually, I wanted to add about this time question, because actually in cybersecurity it comes up a lot too. Like many tools don't have the concept of time, and that's one of the things that we had to add, the ability to deal with time in the models. So I think that's not specific to AI. I think this is something that comes up with any IT system where it was conceived without the notion of time. Then sooner or later we realize that time is a very important dimension to everything we do as humans. And so if we missed time in a certain application, whether it's AI or not AI, we realize sooner or later that we need to put time back in. I just thought that was a great point that you made, Ellie. Somebody is asking, threaten the multifaceted nature of human culture. And I guess AI is just a tool. AI does not threaten our cultures. It's how we use AI that may threaten it. It's just what decisions we make. It's like a gun. Does a gun threaten the life of a child? No, but if it is held by a bad person who wants to do harm to a child, it will, okay? I'm using on purpose a poignant example because we have too many shootings in the US especially. But with AI, we have to be super careful. So we can use it for bad. And that's, I think, I can speak for you, Ellie. That was one of the main drivers of creating your company, to ensure that you can put AI in the hands of various cultures, that they can then train an AI that's aligned with the culture. And so that's what us humans will do with the technology that matters. The technology itself is not a threat. It's what humans will do with it. It's like nuclear energy, right? Can it do more harm than nuclear? I don't know. Chernobyl almost destroyed humanity. Those of you who may have watched the series, those of you who are online maybe and haven't watched Chernobyl, I lived through those times as a child, and I can tell you that series is very realistic. I highly recommend it, and you will see how close humanity came to extinction just with one nuclear reactor's catastrophe, which was not even ill-intended. When some harm is being done, don't even assign it to malice. Often it can happen just by pure incompetence. In that sense, I still would think that nuclear power is more dangerous than AI, but AI is not far behind. It's a toss-up. In some conditions, maybe AI can be more dangerous. In some conditions, I think nuclear power. And then another question from the audience is, one of the challenges with definition is the belief that we can have words mean whatever we want. I guess for Americans, it's Bill Clinton's words. What is the meaning of the, or I don't know what he was trying to get out of his lies, but it's, yeah, that's why I started with the definition. We cannot have a conversation if we don't agree on the definition. I guess that's my answer. Not only we have to define, but we have to make sure we understand the same thing. And as we do contracts as humans, it's the same thing. We have to make sure that we all understand. My lawyer often said that I have clients come to me with a contract, says, my contract says this. And I read the contract and I have to tell my client, no, it doesn't say this. As Mike Tyson would say, what you need most in life is a good lawyer. I'm not paid by the Lawyers Association to say that, and I'm just quoting Mike Tyson here. But that's about definitions. Another question is, you mentioned that you foresee that AI will graduate to know things as good as an expert. Does that imply having specialized models? I think that's a question to you, Ali, so if you want to.
It works in both directions. I think that as AI models grow in size and in amount of data and the quality of data, which you touched upon, and by the way, we use AI models today to enhance bad data, to create new data and good data out of it. I think that we will have a sort of a transition. In the beginning, we will have more of a, in humans as well, when you go to university or high school, you usually learn all of the subjects to a certain degree of competence, but then at some point, you start learning more deeply, and this is if you go into PhD, you basically become very specialized in something. So over the next few years, first we will have models which are higher and higher competence in most of the areas, but then in order to go even deeper and become as good as the best experts, they will have to become experts, and that will change the model from being a sort of jack of all trades to becoming a master of just one specific topic. And then we'll have multiple models that are, each one of them is master of another topic.
Thank you. We're streaming across 5 continents. Thank you very much, Google and YouTube. You guys are awesome. And you guys are one of the biggest AI companies as well. And we love using those tools. Big thanks to our indirect technology support people there.